Hello, space explorers. Imagine a place where the laws of physics simply break. A place where gravity is so strong that not even light, the fastest thing in the universe, can escape. If you fall in, there's no coming back. No signals, no SOS, nothing. These are black holes, the most extreme, terrifying, and fascinating objects in existence. Today, we're diving into the heart of darkness to understand how they work and what happens if you get too close. Let's go. What is a black hole? A black hole isn't actually a hole in the way we think. It's a massive amount of matter packed into an incredibly tiny space. Think of taking the entire Earth and crushing it down until it's the size of a marble. The gravity would become so intense that it would rip a hole in the fabric of space and time. It's not a vacuum cleaner sucking things up. It's a gravitational anchor so powerful that space itself curves inward. How they are born. How do these monsters begin? It starts with a star, but not just any star. We're talking about massive giants, at least 10 to 20 times the size of our sun. When these stars run out of fuel, they can no longer support their own weight. In a fraction of a second, the star collapses and explodes in a supernova. If the core left behind is heavy enough, it keeps shrinking forever, crushing itself into a single point of infinite density. The event horizon. Every black hole has a border called the event horizon. Think of it as the point of no return. Beyond this line, the escape velocity required is higher than the speed of light. Since nothing can go faster than light, nothing can get out. Once you cross the event horizon, the future only leads in one direction, toward the center. It's like a one-way waterfall in space where the water is moving faster than you can ever swim. Spaghettification. So, what happens if you fall in? It's not pretty. Scientists call it spaghettification because gravity is much stronger at your feet than at your head. Your body would be stretched out like a long noodle. You'd literally be pulled apart atom by atom. From your perspective, you'd be falling fast, but to someone watching from the outside, you'd appear to slow down and eventually freeze at the edge, fading away into a faint red glow. The singularity. At the very center of a black hole lies the singularity. This is where our understanding of the universe ends. It's a point where an immense mass is crushed into zero volume. According to the math, the density and gravity here become infinite. Laws of physics that work on Earth simply stop making sense. It's a glitch in the universe, a place where space and time, as we know them, cease to exist. It is the ultimate mystery of modern science. Time dilation. Gravity doesn't just pull on matter. It pulls on time itself. This is called time dilation. If you spend an hour orbiting near a massive black hole, years or even decades could pass back on Earth. It's a real-life time machine. To you, everything feels normal, but the rest of the universe is moving in fast forward. This isn't science fiction, it's Einstein's relativity in action, proving that time is flexible, not fixed. Supermassive giants. Not all black holes are the same size. Most are stellar mass, but then there are the supermassive black holes. These monsters live at the heart of almost every galaxy, including our own. They can be millions or even billions of times heavier than the sun. Scientists aren't entirely sure how they got so big so fast, but they act like gravitational anchors, holding entire galaxies together while slowly consuming anything that wanders too close. Sagittarius A star. Right in the center of our Milky Way sits Sagittarius A star. It's a sleeping giant 4 million times heavier than our sun. For a long time, we couldn't see it because it's hidden behind clouds of gas and dust. But in 2022, the Event Horizon Telescope gave us the first ever image of our own galaxy's heart. It looks like a glowing orange donut of fire, but that light is actually gas spinning at nearly the speed of light before it vanishes forever. Quasars, the brightest lights. It's ironic, but black holes which are totally dark can create the brightest light in the universe. When a supermassive black hole eats a lot of gas at once, the material heats up to billions of degrees. This creates a quasar. A single quasar can shine 1,000 times brighter than all the stars in the Milky Way combined. They act like cosmic lighthouses, visible from billions of light years away, powered by the most destructive force in space. Hawking radiation. Do black holes live forever? Stephen Hawking proved they might not. He theorized that black holes actually leak a tiny bit of energy over time, called Hawking radiation. It's a very slow process, but over trillions and trillions of years, a black hole will eventually lose all its mass and evaporate in a final, massive explosion. Even the most powerful objects in the universe are destined to disappear in the very, very distant future. Do they work like vacuums? A common myth is that black holes go around sucking everything up like a vacuum cleaner. That's actually false. If you replaced our sun with a black hole of the exact same mass, Earth wouldn't be sucked in. We would just keep orbiting it in the dark. You have to get past a certain distance the event horizon to be trapped. As long as you stay at a safe distance, a black hole is just another massive object in space with a lot of gravity. Spying on the invisible. How do we find something that doesn't emit light? We look for the chaos it causes. We see stars orbiting nothing at impossible speeds, or gas being ripped away from a neighbor star. We also listen for gravitational waves. When two black holes collide, they send ripples through the fabric of spacetime, like a bell ringing across the universe. We can now hear these collisions with massive laser detectors here on Earth. Wormholes and portals. Here is where it gets wild. Could black holes be portals? Some mathematical models suggest that a spinning black hole could create a wormhole, a shortcut to another part of the universe or even a different dimension. However, most scientists think this is impossible in reality. The intense gravity would likely crush the tunnel before anything could pass through. Still, the math allows it, leaving the door open for future discoveries. Black holes and life. Believe it or not, we might owe our existence to black holes. By stirring up gas and controlling how many stars are born in a galaxy, supermassive black holes help shape the environment where solar systems like ours can form. They aren't just destroyers, they are cosmic architects. Without the massive black hole at the center of the Milky Way, our galaxy might have looked completely different, and Earth might never have existed. White holes. If a black hole traps everything, is there an opposite? Some physicists theorize the existence of white holes. These would be regions of space where nothing can enter, and matter and light are constantly being spat out. Some think a white hole is just the other end of a black hole in a different time or universe. We've never seen one, but they are a fascinating mathematical possibility that challenges our view of reality. The future of discovery. We are currently in the golden age of black hole research. With new telescopes and AI, we are learning more every day. We're looking for intermediate black holes, the missing links between small and giant ones. For the next generation of scientists, the mission is clear: to figure out how gravity and quantum mechanics finally fit together. The answer is likely hidden right inside a black hole, waiting for someone to find it. Black holes are a reminder of how much we still don't know. They are the ultimate frontier, where space, time, and matter reach their limit. They are scary, beautiful, and essential to the universe. Next time you look at the stars, remember that there are invisible giants out there, shaping the cosmos in the dark. Thanks for exploring the deep void with us. Stay curious, and keep looking up. See you, space explorers.